Most important section in entire FE exam, statics. Literally 10 out of the 110 questions they give you in your FE examination are from the statics section. So without no further ado, let's jump into this. We are about to smash some engineering problems like a pro. Ever wonder how to calculate the moment of inertia of a trapezoid about a tilted axis? Sounds complicated, isn't it? Wrong. I'm going to break it down into three super simple formulas and you can crush it on FE examination. Let's go. Before jumping into the formulas, look at this diagram here. It's a clear trapezoid. So the first step that we have to do is go to the moment of inertia section in your reference manual and then locate exactly where is the trapezoid formula, right? So let's click in moment of inertia over here, click search, something popped up. Now it might or might not be right. Let's see. I don't see the diagrams of trapezoid, square, rectangle and all that stuff over here. So let me just keep searching till I get to the right place. Here you go. This is what I'm talking about, guys. This is exact page that you got to be in. This is page number 69 in statics section. Got it? So that is where we get to see our dear trapezoid. Here you see the breadth B, height H, and small length A, centroid C, x-axis and y-axis. And we also see area and centroid, area, moment of inertia formulas, radius of gyration and product of inertia. What we need is the area moment of inertia, right? Now let's get back to the question real quick and check what is required. We want moment of inertia of area, but about the x dash axis, guys. It's not about centroid. But as I was already showing you, all the formulas that are listed over here are moment of inertia about the centroid. That is the reason it is listed as IXC. Got it? Now let me give you a quick recap about finding moment of inertia about x-axis and y-axis. This is called moment of inertia parallel axis theorem. Please listen very carefully because this is the core concept. The moment of inertia about x-axis is calculated as I dash x, where IXC is the moment of inertia of the centroid, dy is the distance of the centroid from the y-axis, and A is the area of the object in question. Now let me talk to you about the fundamental theorem of calculating moment of inertia about x-axis. That is the moment of inertia parallel axis theorem. I dash x is the moment of inertia about x-axis, which is equal to Ixc, which is the moment of inertia formula we saw earlier, plus dy square, where dy is the distance of centroid c from x-axis. Dx is distance of centroid from y-axis. Be very careful when you do these notations. A is the area, and moment of inertia about x and moment of inertia of about y both are very different formulas, guys. These are two different formulas. So we only want moment of inertia about x-axis. This is what we will note down as equation 1. Ixc, we will note that down as equation 2, and then we will get to finding out the area. That is the plan. Now let's go real quick and take a quick look over here. Here we also have area listed as A is equal to H into A plus B by 2, and also YC or dy of the distance of centroid from the x-axis, that is also listed. So all the formulas we want, A, IXC, all three of them have been listed over here. So from what we discussed, this is equation 1 from the parallel axis theorem. And for this we want IXC, and IXC is going to be the equation number 2 from parallel axis theorem. Then we want A. So A is going to be this. This is the equation number 3 from the parallel axis theorem. And also last but not least, we also have dy. Dy is what again? Distance of the centroid from the x-axis. Actually, dy is a broader term not just limited to centroid, guys. It can be centroid as well, but it can be any given axis. Like in this question, for example, as you can see, they are asking about a particular axis, that is x dash distance from x axis. That's why they clearly asked here x dash axis. This is not, this could have been centroid as well, but in this particular case, it's not. If it is centroid, actually there is much more simpler formulas, but in this case it's not. So here this 3.5 inches is the distance of this x dash axis from x. Okay, this is a small thing you need to remember when we are using this. So for this particular case, this is equal to the dy. So simply put, dy is equal to 3.5 inches. I hope you got this. Now that we got a general understanding of this problem, if any one of you want to give it a try, feel free to pause the video at this point and give it a shot. And now for those of you who would want to know exactly how to go this step by step, let me explain you in detail. So let me just pull this over there. Now let's see. In this centroid, A over here is equal to 3 inches and B is equal to 6 inches. H is equal to height from x axis to the top of this trapezoid, that is equal to 6 inches as well. You know A, B and H as well. So with this information, you will be able to calculate h cube into a square plus 4ab plus b square by 36 into a plus b. That will look exactly like this. Ixc is equal to h cube into blah blah blah. With substitution, you will be getting Ixc is equal to 6 cube into 3 square plus 4 into 3 into 6 plus 6 square by 36 into 3 plus 6. Once you put it in your calculator and solve it, you will be getting 78 inches. Inch to the power 4, not inches. Units are very important because this is moment of inertia. This is going to be inch to the power 4. Got it? Now, once you calculate Ixc, the next term that we need to calculate Ix dash is A. A, like I was showing you before from the reference manual, now A is equal to h into a plus b by 2. That is exactly what I wrote over here. H is 6, A is 3, B is 6. Substituting everything, you get 27 inch square. Got it? So that is gonna be your A. Now you already know Ixc and you already know A, and I already told you dy value is nothing but 4.5 inch, right? X dash is 4.5 inches from x axis. So dy is equal to 4.5 inches. Substituting all of this into Ix dash formula, we get Ix dash is equal to 78 plus 27 into 3.5 square. Once you solve everything, you are going to get Ix dash is equal to 408.75 inch power 4. Super duper easy. All you have to do is be careful and implement one formula at one time, and you will definitely get the correct answer, guys. All right, I'll see you in the next one.